This video is part of consumer theory. In it, I will present budget constraints. Before I present budget constraints, first let's look at the big picture idea of the model of consumer theory that I'm about to start building. There are three premises of this model. The first is that consumers face a budget constraint that's defined based on their income and the market prices of the goods and services that they buy. Two, consumers have tastes or preferences that determine the amount of pleasure they derive from consuming goods and services. And three, consumers maximize their well-being or pleasure from consuming goods and services subject to the budget constraint that they face. Importantly, this video will only consider budget constraints. That is, we're going to, for now, ignore preferences, what consumers desire, and decisions, what they actually choose, to only focus on what consumers could afford given their income and market prices. First, let me introduce some notation. We will assume for simplicity that consumers consume only two goods. Now, does this mean we think consumers only consume two goods? No. What it means is that we are either only going to look at a consumer's budget for two goods at a time, or, as I'll show you later, we might let one of those two goods represent a catch-all or composite good for everything other than some other good that has our interest. This is a simplifying assumption, this assumption of only two goods, which helps with our math and also allows us to graph budget constraints on a two-dimensional graph. We will let the price of X be represented as P sub X and the price of Y as P sub Y. We will also assume that income is represented by the letter I. Another assumption we're going to make for simplicity is that consumers can't save or borrow. Now, in reality, we know this is not true, but as it turns out, starting the model with this assumption doesn't change its predictive power, and in fact, we can pretty easily add in saving or add in borrowing later using the same model. Because we assume consumers can't save or borrow, their income each period will exactly equal their expenditure. This is the expression for the budget line. Again, it says income, or I, equals expenditure on X, or the price per unit times the number of units purchased, plus expenditure on Y, or the price of Y times the number of units of Y consumed. Let's now graph our budget line. Again, the equation for the budget line is I equals expenditure on X plus expenditure on Y. When we graph a budget constraint, note that we put the goods on the axes, good X on the X-axis and good Y on the Y-axis. These are units of good X and units of good Y, not prices. This is how many units of each good the consumer could buy. One way to graph budget constraints is to take this equation and explicitly solve it for the good on the y-axis. If I algebraically solve for good y, I get the expression that y equals I over py minus px over p of y times x. You might recognize that this is the equation of a line, the intercept of which is I over p of y, and the slope of which is a negative p of x over p of y. We'll talk about this slope later. First, let's focus on the intercepts. Again, the y-intercept, as seen in the equation, is income over the price of y. This is actually pretty intuitive. The y-intercept represents how much y the consumer can afford if she buys no x, or how much y she can afford if she spends all of her income on good y. With I dollars to spend at a price per unit of py dollars, she can afford I divided by py units of good y. Likewise, the x-intercept represents how much of good X the consumer can afford if she buys no Y. With I dollars to spend at a price per unit of P of X, she can afford at most I divided by PX units of X. Most of the time, we can just connect these two intercept dots to form the budget line. The budget line acts like a frontier. You might think of it as a consumption possibility frontier that separates the affordable bundles from the unaffordable bundles. Any bundle or combination of X and Y, both on the budget line and inside of it, is affordable, whereas any bundle outside of the budget line is unaffordable or unattainable. Let's consider the following example. The consumer has an income of $500 to spend on both books and meals. The price per unit of a book is $100 and the price per unit of a meal is $10. Now, when I graph the budget constraint for books and meals, it's completely arbitrary which good goes on the X versus the Y axis. Here I've chosen to plot books on the X axis and meals on the Y axis, though I could have easily switched that. The meals intercept, again, represents how many meals the consumer can afford if she buys no books or spends all of her money on meals. With an income of $500 and a per unit price of $10, the consumer can at most afford 50 meals. The books intercept represents how many books the consumer can afford to buy when he buys no meals. Again, with an income of $500 and a per unit price of $100, that means the consumer can afford at most 5 books. Connecting these two intercept dots allows us to form the budget line. Any bundle on or inside of the line is in what we call the budget set. The budget set is the set of all bundles both under and on the line. In comparison, any bundle on the budget line completely exhausts a consumer's income. So if a bundle's inside the budget line, it's affordable, but it doesn't use up all of the consumer's income. A bundle on the line is also affordable and additionally exhausts the consumer's income. Now let's return to the slope of the budget line. The absolute value of the slope of the budget line is called the marginal rate of transformation, or MRT for short. As I will show you, the MRT equals the price of X divided by the price of Y. To see this first, let's return to the equation for the budget line when solved for the variable Y, or the good on the Y axis. From this equation, we can see that the slope is a negative P of X over P of Y. The slope is the derivative of good Y with respect to good X. That derivative, again, is a negative P of X over a P of Y. In absolute value, this gives us the MRT, which is the price of the good on the X-axis divided by the price of the good on the Y-axis. I can also show you this graphically. From this graph, we can derive the slope of the budget line by using the formula slope equals rise over run. To use this formula, we only need 2 points, any 2 points on this line. The 2 points we're going to use are the intercept points. We're going to move from the y-intercept to the x-intercept. So the rise is going to be the change in y when we go from I over P of y to 0, and the run is the change in x when we go from 0 to I over the price of x. That's what I've done right here. We can use our fraction rules to see how this also equals minus P of x over P of y. We've got I over P of y divided by I over P of x, and that's the negative of it. So we can take the fraction in the numerator and multiply it by the reciprocal of the fraction in the denominator. Doing so allows us to see that the incomes can cancel each other out, leaving us with minus P of X over P of Y. Again, the MRT is the absolute value of this, and so P of X over P of Y. The MRT can be interpreted in three ways. To help you understand these interpretations, let me revisit the example from before with books and meals. Here, the MRT is the price of books, since books is on the x-axis, divided by the price of meals, since meals is on the y-axis. Given the values that price of books is 100 and price of meals is 10, the MRT is 10. 10 is how much of meals a consumer must trade for one more book. And that makes sense because one more book is going to cost $100. What else could have the consumer done with $100? Well, he could have bought 10 meals. So 10 is how many meals the consumer must trade in order to be able to purchase one more book. In that way, 10 is also the opportunity cost of buying another book in terms of meals. The third interpretation is as a relative price. Here, 10 means the price of books is 10 times the price of meals. Finally, let me return to the assumption that we only have two goods. Clearly, this assumption is not realistic. Consumers consume more than two goods. We all know that. One way that we can think about this is that we're focusing on only two goods, where one good is the true good of interest, and the second good is just a catch-all or a composite good for everything else. For example, maybe we are interested in studying food consumption to know how consumption of food will change, for example, when the government introduces food stamps. What we will do is graph food, the good of interest, on the x-axis, and on the y-axis put our composite good called other goods. With the graph set up this way, the MRT becomes the price of food divided by the price of other goods. We usually normalize the price of other goods to be $1. Doing so then means that the price of food is a relative price of food. The price of food relative to the price of everything else.